Hi everyone, good afternoon. Let us all go ahead and start our webinar for today. So first, I'd like to double check if everyone in the room can hear me. Can you please give me a thumbs up or an okay sign or a yes in the chat if you hear me and see me okay? Just making sure that we will be having a smooth webinar today. All right, I can see the thumbs up emoji now and some responses in here. Thank you so much. Thank you. All right, welcome everyone. Thank you so much for joining this webinar, and we are very glad that you are here today. And of course, let us go ahead and prepare our settings and make sure that we are all going about this webinar uninterrupted. So let's go ahead and click on the gear icon on your lower right corner of your screen. Okay, right beside the purple button, there's a gear icon. Okay, and when you click the gear icon, please go to notification settings and make sure that no box is checked. Okay, the boxes should not be checked because a lot of things will pop up on your screen and you won't be able to focus on the webinar if that happens. So yep, just make sure they are unchecked and kindly give me like another round of thumbs up or say done when you are done unchecking or removing the checks from those boxes. Okay, for those who could not hear and see me, I think you would need to rejoin the webinar, maybe refresh your browser or check your internet connection. Wow, thank you so much. Thank you for confirming that you have done the settings part. Okay, so just continue. For those who haven't done the settings part yet, just continue doing so. And I am just going to move over to the next slide for now. If you have any questions, feel free to put them in the chat room, and I'd be more than happy to attend to those questions later on. All right, so welcome to our webinar again. Our topic for today is a low voltage design and electrical design process. And this will be led by our lecturer, Miss Alex Gregory. She is one of the lecturers at EIT, and she is also an AECOM principal engineer. And later on, you will know more about her as she introduces herself to us. Is the volume not okay, guys? Okay, if you're having trouble with the volume, okay, majority says yes, all good. If you're having trouble with the volume, please rejoin. You can leave this session for now, refresh your browser, check your internet settings, and rejoin the webinar. You can always rejoin. Okay, thank you. And let me just address some common questions that I know that will come out later on, just to make sure that everything will go on smoothly. For those who are curious about having a copy of the slides or the video recording, don't worry, because we will be sending out copies of the slides, a PDF copy actually, or a PDF version, and the video recording of this webinar within the next 2 business days via email. So you will be expecting that in your inbox. If you don't see it, please check your junk email as well, or junk folder. And for the certificate of attendance, you don't need to pay anything for that. The certificate is for free, and we will be providing that certificate as long as you request for it. So later on, we will be sharing a QR code and a link for you to be able to request for the certificate. Please note that if you don't request for the certificate, we won't be able to provide one because we would be needing details from you for us to put in the certificate. Okay? And we will be sending that to your email as well within the next 4 business days. Okay? Copy of the slides and the video recording will be sent to your email within the next 2 business days. The certificate of attendance, when you request for it today using the link or the QR code, it will be sent to your email within the next 4 business days as we prepare for those certificates one by one. Okay, thank you so much. Now let's move on. So before I hand you over to Miss Alex, let me go ahead and introduce EIT to everyone. So just a bit of a sneak peek about what EIT is and what we can offer to our students. So EIT, or Engineering Institute of Technology, is a dedicated institute that ensures that our students would receive a world-class education and gain skills that they can immediately implement in the workplace. And we are also one of those few institutes who specializes in engineering. Okay, and we also deliver a variety of courses ranging from a 3-month professional certificate course to diplomas, advanced diplomas, undergraduate and graduate certificates, up to bachelor's, master's, and doctor's degree courses. And we are also industry-oriented program. And I mean, we have industry-oriented programs. So our programs are designed by industry experts, just like Miss Alex here and our other lecturers and some members of our academics team. And that is to ensure that our students would graduate with cutting edge skills that are valuable or valued by employers all around the world. Okay, and the content of our program as well will be regularly updated so that it can keep up with the ever-changing technology, especially in the engineering world. And aside from that, we also have world-class Australia accredited education. So, of course, we are accredited by the Australian government when it comes to our courses. So we are accredited by ASQA for our vet courses, and we also have TEXA for our higher education courses. And for our on-campus courses for international students, we are also accredited by QUICUS. And of course, the most prestigious one would be, or the most known one would be Engineers Australia. That's what mostly students would look for when it comes to accreditation. And we have certain courses that are accredited by Engineers Australia, and there are 3 accords. So we have the Washington Accord, the Sydney Accord, and the Dublin Accord. And we also have industry experience lecturers. We are very proud to have Miss Alex Gregory here. She is one of those, and a lot more that you will encounter and meet when you continuously join our upcoming webinars or if you enroll in one of our courses. And of course, they are experts in the industry because they don't just teach engineering or do lectures, but they are also practicing what they teach you or what they share to you in the classroom in the real life. And of course, we have both online and on-campus setup. And of course, we also have a global pool of experts. Our lecturers do not only come from Australia, but we also have lecturers coming from different parts of the globe to make sure that our students would be exposed to different facets of engineering in the whole world. And we also have a unique delivery model We deliver our programs via a unique delivery methodology. And of course, that would be through live and interactive webinars for those who are having online classes. And we also have face-to-face classroom lectures for those who are taking on-campus classes in our higher education courses. And of course, with the help of our international pool of expert lecturers, our learning program is designed well. And we also have our learning support officers who are dedicated to help the student all throughout the learning journey or all throughout his stay at EIT. So those are the go-to persons of the students with any issues relating to their studies. And we also have state-of-the-art facilities, such as our simulation software and our remote laboratories as well. So our simulation software is when you um, navigate or manipulate something virtually within that software. So you are allowed to make mistakes and, experiments and learn from it. And we also have our remote laboratory. That is when you control our equipment in our physical laboratory using your computer. So we have a system for that we give access to our enrolled students. And that would be it. And that's what EIT is all about. And I hope that it can help you in your decision making when you're interested to study at EIT. Thank you. And now let's have our presenter or lecturer, Ms. Alex Gregory. Ms. Alex, I would now give you the liberty to say more about yourself to us. Thank you.
No worries. Thank you for the introduction. Welcome, everyone. Looks like we have a fantastic turnout for today, so I appreciate everyone jumping online to learn a bit more about the LV design process. So as you can see up here, I am a lecturer at EIT, but by day I am an electrical engineer in the design consultancy space. So I work at AECOM over in Brisbane in Australia, and I am a chartered engineer, a registered professional engineer, both in my state and in the nation in our NER register. So I do live and breathe what we're going to talk about today. So hopefully it makes a bit more sense from an industry background. So let's jump in. So today we're going to be running through 4 different packages. First of all, we're going to kick it off with how to start a project. So your project planning, or what we like to call your storyboarding, which is the very start. Then we're going to talk through, at a high level, the electrical design process from start to finish, and then delve into each of the design stages in a bit more detail. And lastly, we'll touch on coordination, because as electrical engineers, whether you're in design, construction, or other industries, we essentially interface with every other service. So we're going to just discuss a few key points about the challenges of that. All right, so you're kicking off a project. You're at your planning stage at the very onset. So what do we like to do from a low voltage perspective? So what is a storyboard? Your storyboard is your plan. Now, we do this at the very start of your design phase. So maybe you've got a early design phase, a detailed design phase, and then a later phase. We do this at the beginning. And the whole purpose is to sit down and really map out what you're going to be putting on your design drawings. So what are you doing in terms of power and lighting, or do you need lightning protection? What other avenues do you need to think of that will form part of your design process? And the reason this is useful is because we can quantify how much work is actually needed. So a small project may need less drawings, and therefore it might need less drafting time or modeling time. And what comes out of this is the beginning of our drawing list, which some of you might know as our deliverables list. And that's the key outcome for this storyboarding process. So essentially, it is that plan what do we expect we're going to be doing from a electrical design perspective specific to this particular project. So why do we bother planning? Well, it's not just an electrical engineering skill, it's applicable to all forms of engineering and all forms of business. Planning is key because it outlines or helps us come up with what we need to know from the beginning. So what information are we going to need from other people, from the client, from the site to inform our design? Then we know what we need to set up. So that could be drawings, that could be meetings, that could be obtaining information. And we do all of that before we actually start our design. So it's that time spent preparing yourself before jumping straight into doing any form of calculations. Now, often what's involved in a project might come from a client brief. So we might spend time understanding what we've been engaged for or what's the purpose of our design. We need to understand what the client is expecting, whether it's a new facility or a refurbishment. What are they envisioning when they're engaging designers to do some new work? And once we've had that plan in mind, then we can discuss it and agree it with someone else. So we get that sounding board. We make sure whether it's your team lead, whether it's your supervising engineer, you map out what you're planning on doing so you can start your project on the right track. So some of the questions we like to ask. First of all, what are the deliverables? Have we already been told what we're producing? Maybe we're just producing a document. Maybe we're producing drawings. Maybe we are investigating an issue at a particular installation and we're producing a report of our findings. If we are producing drawings, we need to know what type. Maybe they're markups on PDFs. Maybe they're a fully coordinated model. What is our deadline? So how long do we have to produce what we need to produce? Has that already been agreed? What scope have we been asked for? So maybe we're looking at a lighting issue, but we go out and find other issues to do with switchboards and power. And maybe that's not what the scope was meant to be for our engagement. And lastly, how much budget or time do we have to do the works? So hopefully these two items coordinate. We have enough budget and enough time, but it's still worth asking the question before jumping in. So as a team or as an individual, it's all about staying organized. If it's a really large project, then maybe we need to make sure we've got enough people to do the work, enough electrical engineers. And how are we going to divvy up the tasks that they're doing? So we need time to do the design, the right people, people with experience, people with availability. We need employees to do the drafting, so perhaps if we are modeling. And lastly, that QA, which is our quality process, making sure your work gets checked or verified. Some of the key filing systems that we use, and again, this varies depending on what you're familiar with and what you personally use, but you might do all this work within project drives. You might use OneNote pages or OneDrive, Outlook groups. Maybe you even use Microsoft Teams or Blackboard as we're using today. So let's talk through our storyboarding. What we've showed here is typical drawings for an electrical design. So when you're running through the project, you can ask yourself, do I need each of these drawings and are they relevant for this size or type of project? So a cover sheet might just say electrical services. Maybe we're doing electrical combined with comms and security for this particular project. More often than not, you have a legend. It's very important to know what your symbols and acronyms mean, and we put that information on the legend. You may or may not have schedules and notes. Perhaps you've got luminaires schedules or equipment schedules, or specific notes if you don't have a specification document. One of the key items is a site plan. So this gives you context of what you're doing in relation to the larger area. So it's very zoomed out, you could say, and it gives positions and maybe external information like pits and conduits and street lights. If you're demolishing anything, you might have a demolition plan. You might need to outline what is being retained and what's not. Then as far as your new services, typically there's 3 drawings. We would dictate new power. We would dictate reticulation, which is cable trays, catenary, things like that. How you get your cables to and from key pieces of equipment. And then as well lighting. So this is lighting as well as lighting controls and your exit and emergency lighting. After that, we have our SLDs. Now these are your single line diagrams or your schematics. So that's where you have information relating to your switchboards or your load centers. So they're also very important. And the last one, which again is optional, is detailed drawings. So if you've got anything that you need to particularly detail out, you can include them in the back. Maybe they're how you connect a certain PowerPoint to a column, or maybe it's details of a solar array or a specific scope of work. So that's an optional one that would be specific to your project. So that's a high-level overview. We've planned our project, we've sat down, we've thought about what we're going to produce, what drawings we expect. Now we jump into what order we do our actual electrical design in, so that we don't jump around. All right, so we split it into 3 different categories. First of all is your infrastructure. So this is things like switchboards. What we like to do for our infrastructure is the first step is always the load. Where do we start? What load do we need? That will tell you how many switchboards you would need, or maybe you need a substation with a transformer. Once we know that, we can do our spatials. So spatials are sizing your plant space. Do you need a main switchboard room? And how big should it be? Because what's going in it? Do you have distribution boards that would require cupboards? So we feed this information in very early on to get plant spaces allocated. We then look at reticulation. So how do we get cabling between those plant spaces from our main switchboard to your second building, or from your main switchboard room to your distribution board? And that will help us come up with a very high level or a skeleton single line diagram. So it's not detailed, it just outlines your key infrastructure. Your switchboards, maybe you have UPS, maybe you've got a main switchboard with 2 distribution boards. We'll work that out through this infrastructure process. So typically, this first step is done very early in the project. Once you move into your detailed design, we start working through our design process. So typically this means we've got power, being power layouts, lighting, like we've spoken about, your maximum demand, which is your MD, so your detailed load. So unlike using VA rates, which is just based on square meterage, you've actually got your equipment and you're doing a detailed load calculation. We can then refine our single line diagrams and finish up our containment, so actually sizing our cable trays. Again, depending on your type of project, you may or may not have any of the following. details around lightning protection. Maybe you've got healthcare that involves nurse call. Your exit and emergency lighting. Most buildings would, but again, you might detail that out separately. Maybe your drawing set will include comms, security, and even AV, and then some additional details. So there's a fair amount, as you can see on this slide, that goes into an electrical design. So we've spoken a bit about it, so I'm going to run through a bit more dot points of what is within each of these categories here. So infrastructure, we do our high-level load calc. How much power do we think we need? VA, which is volt ampere, VA rates are typically used, so just based on square meterage, normal power lighting fit out, we can work out our total load. And then we ask ourselves, is there enough power? And if not, well, what size and type do we need? Is it single phase, three phase? How much of it? Then we look at our power strategy. So where will we get that power from? Do we have a building suitable just for a single switchboard, or do we need multiple distribution boards? And are we splitting out other services? So is there a mechanical switchboard, or does that all come off of this one switchboard? So what's our general strategy? Then we start selecting, again, our key infrastructure. So things like generators, fuel requirements for them, generator link boxes. Maybe you need a UPS for backup power. How many distribution boards do we need? How big is your building? So that's our high-level infrastructure and is the first step. Then we give that information in terms of plant spaces to our architects. So we start saving space in the floor plans very early on for our main switchboard rooms, our distribution board cupboards, any risers we might need, communication rooms, generator rooms. And we get in early and we save that space for ourselves. We then also outline very roughly our cable reticulation, because maybe we all have combined risers. Maybe we've got set ceiling zones that we're sharing with other services. And by this stage, we should have a good idea of our general power strategy, which means we can do those high-level single line diagrams, especially for our main switchboards and our big infrastructure, like our backup power. So the first step, always infrastructure. Now we normally do this early. Early might be a concept design or a preliminary design. But if it's done correctly, then we get the project set up and it will run smoothly through the detailed design process. Cutting corners in this stage can cause problems later because you may not have enough plant space, or they may not be coordinated with where your generator sits to where your main switchboard sits. So hence, planning at this first point is very important. So an example here is a little snip from a project. You can see here we've sent the floor plan to our architects and we've said, hey, we would like a distribution board cupboard somewhere in here. Please make it this big, and we need a second distribution board cupboard for the kitchen in this area and make it this big. So that's the level of detail that I'm talking about. Now, distribution boards do have distance limits. Obviously, the further apart they are, the bigger your cabling. Now, we want to try and limit that. So sometimes what we do is simple colored blocks and say, well, based on the floor area of this building, we're probably going to need at least 4 or 5 distribution boards. And that way that board can be located anywhere in these colored squares and will still be within approximate distant limitations. On the right here, you can see some sketches of typical distribution board cupboards. So if we've got a double-tiered distribution board, so a 1200 wide, we often ask for a 1.6 meter cupboard. Maybe we have a 3-tier switchboard, which is an 1800 wide, in which case we would need a 2-meter cupboard with some different doors. Or maybe we have an arrangement like this. So by coming up with your general power strategy, it helps you work out your number of dBs and their size, and then we can confirm our spatials. Now here is an example of a skeleton single line diagram. So you can see here, there's not a lot of information. It's very high level. It just shows your power supply arrangement. So here we've got normal supply, generator supply, and a backup connection point for a generator. We've got some life safety. We've got a main chassis. And then in this case, we have a lot of distribution boards. We've got some light and power, some comms, and some mechanical. So this skeleton SLD is what we produce in this infrastructure planning stage. It's high level, but it informs our spatials. Here's an example of a switchboard spatial sketch. So we've done that skeleton SLD. Based on that, I've estimated this switchboard might be up to 10 meters long. From that information, I then size the room that it would need to go in. So here I've sized a room that will suit a main switchboard, a secondary switchboard, some UPS and their batteries, as well as spare space for another switchboard in the future. So by doing your skeleton SLD, you can then size approximately your infrastructure, place it in a room in an arrangement that you will use, and then this will be the main switchboard plant room that I would request from the architects. An 11 meter by 5 meter room very early on in the project. Option B, maybe 11 meters was too wide and that wasn't possible. So then we can go back to the drawing board and say, okay, well, I still know what my switchboard needs to serve. Maybe I'll do a front and back connected switchboard. I'll make it a wider main switchboard, allowing my room to become more of a square shape, and then we can coordinate with the architects to see which out of these two dimensions would work better in their floor plan. Something else we do very early on is if you think you need a bigger power supply, we need to find where that power supply will come from. And sometimes that means talking to your electricity provider. So we might need to do an application to that authority to request an upgrade on the power supply. Now we do this at the start because it can take a very long time for this to occur or to even have the conversations. So we do it early, we keep track of all the correspondence, and it also helps us keep our client informed of any implications that might have. All right, so we've done our infrastructure at a high level. Now we flow through our design process. So as an electrical engineer, we go from power to doing our lighting design. This allows us to update our maximum demand based on how much power and lighting we've got. And that allows us to finish our single line diagrams, because by then we've got the loads, so we can size our cables, we can measure our fault levels, our voltage drop, and finish those single line or those switchboard designs. And by then we can do our containment. So often that just needs the information such as how big are your cables and how many. So once we know our load, we can size our cables and size the containment. So this is the normal order of design. So power layouts, what goes on them? First of all, we need to ask the client what they want. Maybe they really want X number of power outlets, or maybe they have specific equipment that they're going to be installing. Then we want to know how we're populating those floor plans from a drawing perspective. And are we providing power for other services, or is it just general power? Maybe there's lifts or hydraulic pumps, hot water units, communication racks. We need to coordinate with them and provide power where they need it. Similarly with the architects, they could be specifying fridges and billy taps and forklifts, and we need to make sure we've captured all of that FF&E as well. And lastly, we circuit it all. So once we know how much power we need, what type and where, we can work out how many circuits we'll need from our distribution board. So if it's a new project, nice and easy. We can run new cabling as we need. However, if it's a refurbished facility, we might need to have a bit more of a think of how we're actually getting cables from A to B. Similarly, there might be control or AB requirements. So the question of scope that ideally we'd ask in our planning phase, we know whether to fold those into our power layouts or if they'll be on a separate drawing set. Lighting. So what goes on a lighting layout? First of all, we need to pick lights, but to do so, we need to know what type of ceiling we've got. Do we have a ceiling at all, or is it all open? Is it a T-bar or a plasterboard? Then we can model it in certain software. We use AGI or Revit or ELOM tools. In Australia, we might have to do different calculations to do with energy usage, depending on the country that you're in. And then we want to schedule out all the lights that we've picked. Lastly, we'll circuit and switch our lights. So how are the lights controlled? That's known as switching. And where are they powered from? And that's your circuiting. Now for lighting control, you could use various types. It could be manual, it could be smart, Bluetooth. We also use things that we call C-bus, which is your backbone style, or DALI. So often your lighting layout, depending on the complexity of your project, might be fairly detailed. Okay, maximum demand. So we've moved through our design process. We know how much power and where, how many lights and where, and now we're going to review that early maximum demand or power demand that we did at the planning stage. So in Australia, this is all done using AS3000. We have a set standard that allows us to build up our load calculation. And we call it a bottom-up calculation because it's very detailed. It looks at exactly how many GPOs or power outlets, what equipment, what lights, and we sum those together. The key, though, is understanding what's supplied off of which switchboard to make sure you're summing your loads correctly. Don't forget other services if you're powering mechanical or hydraulic or vertical transport. You might need to diversify your load, so if some things only run during the day and some things only run at night, well, those two things won't run at the same time, so we call that a diversified load. Maybe you need to include some spare capacity for future expansion. So it is a bit of work when detailing out your maximum demand to make sure it's your best guess at how much power you need. Then we can do our single line diagrams. So you've seen the skeletal single line diagram. Now we flesh that out with design information. And what I'm talking about is how many chassis arrangements do you have? So that example before had a couple. It had one for light and power, one for mechanical, one for communications. You'll need to confirm your backup power requirements, so generators and UPS. Now, once your single line is complete, you can detail out all your protective devices, so all your sizes and types of circuit breakers, as well as your cables because your circuit breakers are there to protect your cables. And once we have all of that information, we can validate the size of our switchboards. So early on we asked for spatials. Now we know, because of our power and lighting layouts and our loads, exactly how big those switchboards are likely to be based on all the equipment that it is supplying. Containment, this is very specific to each project. So you might have cable tray, you might simply have catenary, you might have cable ladder. Maybe everything is run in conduits. Externally, we typically use conduits in the ground between pits, but we can size how many conduits we need and then work out how big our pits need to be. And it all comes down to how many cables we need to run and how big they are. And we don't know that until having completed all of these steps before. So that's why containment is our last order of design. So some other things which can be done really at any time, but we've just put them here to jog your memory, is lightning protection. So you might do that at any point. Your exit and emergency, we do need to know what the egress paths are going to be, but we could produce some schematics, and we typically do that at the same time as our lighting design. And our details, again, this is completely flexible. It depends what you want to do. Maybe you've got some typical details like cable markers that you always include, or trenching details, but anything that is useful or specific to your project. So they don't fit into that flow of order of design, but are considered outside. Similarly, the other items that we've already spoken about. So outside of our order of design, you might have nurse call layouts, communication drawings, so racks or schematics. You might have a solar design. You might have some security layouts or some dry fire layouts. So these can be done at any point beyond that standard electrical process. All right, so let's deep dive into the design stages. So this isn't what we're producing, such as power, lighting, comms. Instead, this is your design stages as you progress. So what do I mean by that? There is an order of design, and the level of detail that we document varies as you go through a design stage. So we're talking concept, preliminary, all the way through to detailed design. Or you might know them as percentages. You might start at a 5% and finish at 100%. So the bigger the project, often the more design stages we have. A smaller project may have less design stages. It really depends on the size of the job, what the client's wanting, and what you're contracted to do and your budget allows you to do. So here are some examples, and there's no set rule. A large project might run from 5 to 30 to 50, 90, 100. Tenders what is tendered on by the market, and construction is what gets built. You might have an industry that specifically says, no, we want a 30, a 50, a 90, and 100. Or you might have a small project where you just do a preliminary design, then you do a detailed, and then you're finished. So there's no set rule. It does depend on your client and your project size. So I've listed here an example. So we know what activities we do as designers, but how do they fit into those design stages can vary. So at a concept level, we tend to do the high-level activities, meaning a high-level maximum demand, like a VA rate, spatials for your switchboards and plant, your key infrastructure, so your power infrastructure, your reticulation, We don't tend to do things like detailed power or lighting layouts because it's too early for that. As we move from concept to schematic, or you could say from a 30% to a 50%, we're still going through similar design processes but in more detail. So a more refined maximum demand. We've confirmed those sizes for rooms that we've asked for. We've preliminary sized some containment and some equipment. Maybe we've looked at lighting levels but not light fittings, and a general strategy but not selections. So it's a bit more detail, but it's not finished. So depending on the design stage, will often dictate what design activities you do. But in general, we move through at a detailed design stage. So this is all of the design processes. We size our cables, which allows us to select our protective devices, our fuses and our circuit breakers. Because we have a final MD, we can confirm our equipment size. So how big is our switchboard? We can finalize that size. This then allows us, we can finalize that size. This then allows us to model our fault levels, our voltage drop, our containment. Once we've done our lighting, we typically then do our lighting controls. And we can finish exit and emergency and do some energy calculations if we need to. So in a detailed design, or you could call that, say, a 90%, we do all of these activities. All right, so we've done 3 parts of today's webinar. To finish off, I'm just going to touch on the challenge of coordination. So it's called that because electrical infrastructure interfaces with everyone else, and often that is challenging. So what I mean by that is, who do we coordinate with as electrical engineers? The answer is everyone. We interface with mechanical and hydraulic, fire, comms and AV, security, vertical transportation, so your lifts and escalators, acoustics, structures, as well as the building certifier. We have to liaise with all of those disciplines. So the challenge is, we need a lot of this information up front. When we're trying to do that high-level maximum demand, well, we need to know what other services there are and what information or equipment they're expecting. Now, often we need to know a little bit about everything because we're the first to start as electrical, and then we're the last to finish. And like I said, we interface the most with everyone else. So it's all about coordination. Coordination is key. If we miss something, then often if there's no power where power is needed, well, that's because there's an issue with the electrical design. So we need to really spend time in coordination. So for mechanical, this is some of the things that they have. Now I won't go through this in too much detail because this is an electrical webinar. However, some of these might jog your memory. So mechanical switchboards, control panels, they might have meters, they might have a building management system, or maybe we need to share ceiling space with them. We also could have service panels, or maybe they're helping with our fuel systems. We need to know, or they would like to know how much heat our equipment puts out so that they can design the ventilation. Maybe it's medical, so they could have pneumatic tubes or medical gas panels, or coordinating within a ceiling where we recess equipment. Structural. Anything from penetrations such as cable risers, or if we've got any equipment that's very heavy, Lightning protection is probably the biggest coordination piece we do with structures because we often use the structure for our design. They help us with our trenches, providing us plinths for our boards or bunds for our generators. We often cast in conduits into their walls or into the floor to get to floor boxes. They help us with earthquake designs or really large pits, or footings for pole-mounted lights, or even supports for things on the roof like solar panels. For fire, could be anything from pumps, whether it's diesel or electric. Maybe they're providing some life safety services like sprinklers or deluge systems. They'll have rooms that we need to fit out for power and lighting. We have to coordinate on sealing between their detectors and our light fittings, or their gas fittings. Maybe they've even got specific requirements for fire engineering that we need to allow for. For vertical transportation, this one's fairly straightforward. It's lifts, cranes, vehicle hoists, escalators. So we coordinate with them to make sure we provide sufficient power for all of those items. Now, sometimes electrical includes ICT, which is comms, sometimes it doesn't. If we're coordinating, well, we need to know where they need power and what their equipment loads are. What type of equipment? It could be desk, projectors, CCTV, communication racks. Maybe they have backup power requirements because they're a very important service. And maybe you need to monitor some of their equipment. So, we often provide emergency lighting in all comms rooms because if you lose power, you need to make sure your comms are still running. Some more comms requirements. The UPS we've spoken about, but floor boxes. Maybe you have an office and we're sharing floor boxes. Power on one side, comms on the other. We need to coordinate those things. Security, very similar. Where are their security panels? What do they need? Do they need general power? Do they have CCTV? Does our lighting need to be of a specific level for their CCTV to operate? Where are their security boom gates or sliding doors? Key safes, any particular equipment they have. For hydraulic, this could be anything from trap primers to hot water units, sewage treatment plants, rainwater tanks, rainwater pumps. How do we connect to that equipment? We need all this information or have these discussions during that planning phase. Drinking fountains, sensor taps, eyewash safety showers, hot water units, irrigation. Maybe there's a water feature. Anything that requires power or lighting, we have to coordinate. Now for civil, it is similar to structural, but we're talking more external work. So our pits and our conduits, drainage in our pits, we can make sure everything's out of our flood levels. In-ground services is probably the biggest piece. So we need to coordinate between anything in-ground for power to make sure we have enough cover and enough separation to their services. So some common areas we see. Switchboards on egress paths. So you can't have a switchboard where people need to evacuate unless you can prevent smoke from filling that evacuation path. We often need to coordinate with mechanical. If they need to monitor anything on the building management system, we need to tell them. And in general, at the more points we coordinate, we need to know whether other services are stopping and where electrical is starting, or vice versa. And lastly, sometimes, despite all of this, it still doesn't get coordinated. So this is a photo from one of my projects. And as you can see, electrical contractor installed our light first and hydraulic contractor just made it work on site. So it's not ideal, but it still happens. But coordination needs to continue, not just in design, but onto site construction as well. So just to summarize what we've run through today, starting your project right is the best way forward. Really do that storyboarding process and know what you have to do, how much time you've got to do it, and what you'll produce. Then work through your design, the key being your infrastructure. If you get that right, the rest is just your design, the key being your infrastructure. If you get that right, the rest is just detailing. Lock in your spatials early and only document as you need for each design stage. And lastly, coordinate. Coordination starts early and it is all the way there until the end. We need to coordinate with everyone, so just keep that in mind. Thank you. So I'll hand you back to Lisa, but I hope that that's been an informative webinar as far as LV design process.
Hey, Alex.
Hello.
Yeah. I believe there are certain technical questions. If you think you're done with them, then I can go ahead and continue with the slides.
Sure, I'll do some in the background.
Okay. Thank you so much, guys. And thank you so much, Alex, for the new learnings that you are sharing to everyone today. And I would just like to inform everyone about these upcoming courses that we have at EIT. So as you can see from the slide, we have our electrical related engineering courses. We have one upcoming on Monday, the professional certificate of competency in smart grids. Maybe you'd like to check that out. We also have our professional certificate of competency in hydrogen energy production, delivery, storage, and use on the 9th of October. We have an advanced diploma of applied electrical engineering on the 16th of October, and another professional certificate of competency. This time it's for the earthing and lightning protection, which is on the 6th of November. And another one on the 6th of November, which is the professional certificate of competency in power distribution. On the 13th of November, we have the professional certificate of competency in electrical power system fundamentals for non-electrical engineers. We also have our graduate diploma of engineering electrical systems on the 2nd of January. And if you want to have a master's degree instead in electrical systems, we also have one starting on the 2nd of January, and another professional certificate of competency in substation design main equipment on the 16th of January. And lastly, we have the advanced diploma of electrical and instrumentation, or E&I engineering for oil and gas facilities, on the 16th of January next year. All right. And if you would like to join our upcoming events and webinars, you can freely go to our website. That's www.eit.edu.au/news-events/events. And that's how you can access our events and webinars. And our upcoming webinars next week, we have on the 5th of October, the HVAC system sizing based on computational fluid dynamics. We also have our low voltage design coordinating with others on the 11th of October, and low voltage design maximum demand on the 18th of October. We also have our EIT virtual open week on the 23rd of October. And we are looking forward for you to be there as well, especially in our EIT Virtual Open Week. We will be answering all your questions regarding our courses and our application process and many other things that you are concerned about. And for those who would like to request for the certificate, then you can access this, you can scan this QR code, and I will also paste the link in our chat room. Just give me a moment here. Please note, guys, that if you don't request for the certificate, you won't be able to receive it as well. So please make sure that you would be able to request for that certificate through the QR code or through the links that I'll be sharing shortly. If you have any questions, feel free to put in the chat, especially questions regarding the topic today. And Miss Alex would be more than happy to answer that for you. And I have sent the link to request for the certificate in our chat room. And I hope that everyone can see it. Right? So I'll just give everyone a minute to scan to request for the certificate. All right. Victor has a question here. I would just like to address that quickly. So, Victor, you would like to know when is the advanced diploma of industrial automation engineering starting? We have an intake this coming 16th of October, and the deadline to apply for that would be on the 9th of October. We also have another intake on the 6th of February next year. And again, we highly recommend that you apply for the course on or before 7 days prior to the start date. All right, now let's move on. So you can continue on with your questions as we go along, guys. And I would just like to share our contact information. You can access our website at www.eit.edu.au. Our head office is in 1031 Wellington Street, West Perth, in Perth, Western Australia. And you can also give us a phone call if you want. For those who are inside Australia, you can use 1300 138522. For those who are outside Australia, you can use +61 89 321 1702. And if you'd like to send us an email regarding webinar concerns, like following up on your certificates or questions about this webinar or any webinar related questions, you can send an email to webinars@eit.edu.au. And if you would like to know the list of courses that we are offering and their upcoming intakes as well, please go to www.eit.edu.au/schedule, and you can see all of the upcoming courses with their corresponding intake dates in there. And again, just a reminder for everyone, make sure that you request for the certificate. If you haven't scanned the QR code, please use the link that I am sharing in the chat room right now. And please request for your certificate of attendance up until Sunday afternoon only. That's our cutoff. Anything beyond that will no longer be acknowledged. So please be mindful of the deadline. If you can request it as early as now, that would be a lot better. But the latest to request for the certificate would be Sunday afternoon. For those who are asking for a copy of the recording and the slides, we will be sending it out to everyone. We will send it to your email in the next 2 business days. So please check your inbox or your spam folders or junk folders in the next 2 business days, because we will surely send a copy, a PDF copy of the slides and the recording as well of this webinar. If you have further questions, feel free to send it to webinars@eit.edu.au. Even if it is for Miss Alex, we will be glad to forward it to her so that she can also give us the answer. And thank you so much, everyone, for attending the webinar today. We hope to see you in the upcoming webinars as well related to electrical. And for those who are interested in our courses, feel free to reach out through the website or through phone or through email, and we would be more than happy to assist you in your application or enrollment. Okay, please note that our campuses are in Melbourne and in Perth. We don't have a campus yet in Sydney or other areas in Australia. So for those who are not based in Perth or Melbourne, you can always access our online courses like the professional certificates and the advanced diploma courses. They are offered online, so you don't need to go to Perth or to Melbourne for that. So I hope that it will help you in your decision making as well. Okay, I'm just checking here for more questions. Thank you so much for your messages, guys. For any questions that we missed, just send an email to webinars@eit.edu.au. I'm sending again the link to the certificate just to make sure that everyone is getting it. And again, please submit your request on or before Sunday afternoon this week. Thank you so much, everyone. I am going to end the webinar now, and may you have a great day today. See you soon. Bye.